In computer programming, a parameter is a special kind of variable, used in a subroutine to refer to one of the pieces of data provided as input to the subroutine. These pieces of data are called arguments. An ordered list of parameters is usually included in the definition of a subroutine, so that, each time the subroutine is called, its arguments for that call can be assigned to the corresponding parameters. Just as in standard mathematical usage, the argument is thus the actual input passed to a function, procedure, or routine, whereas the parameter is the variable inside the implementation of the subroutine. For example, if one defines the add subroutine as def add, return x plus y, then x, y are parameters, while if this is called as add, then 2, 3 are the arguments. Note that variables from the calling context can be arguments. If the subroutine is called as a equals 2, b equals 3, add, then the variables a, b are the arguments, not only the values 2. See the parameters and arguments section for more information. In the most common case, call by value, a parameter acts within the subroutine as a variable initialized to the value of the argument copy of the argument if the argument is a variable. But in other cases, e.g., call by reference, the argument supplied by the caller can be affected by actions within the called subroutine. In call by value, one can thus think of arguments as values, but in general arguments are not simply values. The semantics for how parameters can be declared and how the arguments are passed to the parameters of subroutines are defined by the language, but the details of how this is represented in any particular computer system depend on the calling conventions of that system. Example: the following program in the C programming language defines a function that is named sales_tax and has one parameter named price. The type of price is double. The function's return type is also a double. Double sales_tax return 0.05 price. After the function has been defined, it can be invoked as follows: sales_tax. In this example, the function has been invoked with the number 10.00. When this happens, 10.00 will be assigned to price, and the function begins calculating its result. The steps for producing the result are specified below. Enclosed in 0.05 price indicates that the first thing to do is multiply 0.05 by the value of price, which gives 0.50. Return means the function will produce the result of 0.05 price. Therefore, the final result is 0.50. Parameters and arguments. The terms parameter and argument are sometimes used interchangeably, and the context is used to distinguish the meaning. The term parameter is often used to refer to the variable as found in the function definition, while argument refers to the actual input passed. For example, if one defines a function as def f, then x is the parameter, while if it called by a equals f, then a is the argument. In both cases a parameter is an variable, while the argument can be thought of as a value or variable, depending on the calling convention. In case of call by value, one can think of the argument as a value. For example, f and a equals 2, f are equivalent calls, while in call by reference one can think of the argument as a variable in the calling context. Parameters appear in procedure definitions, arguments appear in procedure calls. In the function definition f equals x asterisk x, the variable x is a parameter. In the function call f, the value 2 is the argument of the function. Loosely, a parameter is a type, and an argument is an instance. A parameter is an intrinsic property of the procedure, included in its definition. For example, in many languages, a procedure to add two supplied integers together and calculate the sum would need two parameters, one for each integer. In general, a procedure may be defined with any number of parameters, or no parameters at all. If a procedure has parameters, the part of its definition that specifies the parameters is called its parameter list. By contrast, the arguments are the values supplied to the procedure when it is called. Unlike the parameters, which form an unchanging part of the procedure's definition, the arguments may vary from call to call. Each time a procedure is called, the part of the procedure call that specifies the arguments is called the argument list. Although parameters are also commonly referred to as arguments, arguments are more properly thought of as the actual values or references assigned to the parameter variables when the subroutine is called at runtime. When discussing code that is calling into a subroutine, any values or references passed into the subroutine are the arguments, and the place in the code where these values or references are given is the parameter list. When discussing the code inside the subroutine definition, the variables in the subroutine's parameter list are the parameters, while the values of the parameters at runtime are the arguments. For example, in C, when dealing with threads, it's common to pass in an argument of type void asterisk and cast it to an expected type. Void thread function, naming the first parameter, thread argument, is correct, rather than thread parameter. At runtime, the value we use is an argument. As mentioned above, reserve the term parameter for when discussing subroutine definitions. To better understand the difference, consider the following function written in C. Int sum, return addend1 plus addend2. The function sum has two parameters, named addend1 and addend2. It adds the values passed into the parameters, and returns the result to the subroutine's caller. The code which calls the sum function might look like this. Int sum value, int value 1 equals 40, int value 2 equals 2, sum value equals sum. The variables value 1 and value 2 are initialized with values. Value 1 and value 2 are both arguments to the sum function in this context. At runtime, the values assigned to these variables are passed to the function sum as arguments. In the sum function, the parameters addend1 and addend2 are evaluated, yielding the arguments 40 and 2, respectively. The values of the arguments are added, and the result is returned to the caller, where it is assigned to the variable sum value. Because of the difference between parameters and arguments, it is possible to supply inappropriate arguments to a procedure. Any of these situations causes a mismatch between the parameter and argument lists, and the procedure will often return an unintended answer or generate a runtime error. Alternative convention in Eiffel. Within the Eiffel software development method and language, the terms argument and parameter have distinct uses established by convention. The term argument is used exclusively in reference to a routine's inputs, and the term parameter is used exclusively in type parameterization for generic classes. Consider the following routine definition. Sum integer do result equals addend1 plus addend2, and the routine sum takes two arguments addend1 and addend2, which are called the routine's formal arguments. A call to sum specifies actual arguments, as shown below, with value 1 and value 2. Sum underscore value, integer value 1, integer equals 40 value 2, integer equals 2, sum underscore value equals sum. Parameters are also thought of as either formal or actual. Formal generic parameters are used in the definition of generic classes. In the example below, the class #table is declared as a generic class which has two formal generic parameters, G representing data of interest and K representing the hash key for the data. Class #table, G, K to hashable. When a class becomes a client to #table, the formal generic parameters are substituted with actual generic parameters in a generic derivation. In the following attribute declaration, my_dictionary is to be used as a character string-based dictionary. As such, both data and key formal generic parameters are substituted with actual generic parameters of type string. My_dictionary, #table, string, data types. In strongly typed programming languages, each parameter's type must be specified in the procedure declaration. Languages using type inference attempt to discover the types automatically from the function's body and usage. Dynamically typed programming languages defer type resolution until runtime. Weakly typed languages perform little to no type resolution, relying instead on the programmer for correctness. Some languages use a special keyword to indicate that the subroutine has no parameters. In formal type theory, such functions take an empty parameter list. Argument passing. The exact mechanism for assigning arguments to parameters, called argument passing, depends upon the evaluation strategy used for that parameter, which may be specified using keywords. Default arguments. Some programming languages such as Ada, C++, Clojure, Common Lisp, Fortran 90, Python, Ruby, TCL, and Windows PowerShell allow for a default argument to be explicitly or implicitly given in a subroutine's declaration. This allows the caller to omit that argument when calling the subroutine. If the default argument is explicitly given, then that value is used if it is not provided by the caller. If the default argument is implicit, then the language provides a well-known value if a value is not provided by the caller. PowerShell example. Function doc $G gigawatts $G gigawatts. Great Scott, PS greater than doc 1.21 gigawatts 1.21 gigawatts. Great Scott, PS greater than doc 88 gigawatts 88 gigawatts. Great Scott. Default arguments can be seen as a special case of the variable length argument list. Variable length parameter lists. Some languages allow subroutines to be defined to accept a variable number of arguments. For such languages, the subroutines must iterate through the list of arguments. PowerShell example. Function Marty $args $4arg back to the year $_ PS greater than Marty 1985 back to the year 1985 PS greater than Marty 2015 1985 1955 back to the year 2015 back to the year 1985 back to the year 1955. Named parameters. Some programming languages, such as Ada and Windows PowerShell, allow subroutines to have named parameters. This allows the calling code to be more self-documenting. It also provides more flexibility to the caller, often allowing the order of the arguments to be changed, or for arguments to be omitted as needed. PowerShell example. Function Jennifer, young Jennifer. I'm $adjective young, old Jennifer. I'm $adjective old, PS greater than Jennifer, fresh, experienced, young Jennifer. I'm fresh, old Jennifer. I'm experienced. PS greater than Jennifer, adjective old, experienced, adjective young, fresh, young Jennifer. I'm fresh, old Jennifer. I'm experienced. Multiple parameters in functional languages. In lambda calculus, each function has exactly one parameter. What is thought of as functions with multiple parameters is usually represented in lambda calculus as a function which takes the first argument and returns a function which takes the rest of the arguments. This is a transformation known as currying. Some programming languages, like ML and Haskell, follow this scheme. In these languages, every function has exactly one parameter, and what may look like the definition of a function of multiple parameters is actually syntactic sugar for the definition of a function that returns a function, etc. Function application is left associative in these languages as well as in lambda calculus. So what looks like an application of a function to multiple arguments is correctly evaluated as the function applied to the first argument, then the resulting function applied to the second argument, etc.